Good evening, everyone. Welcome to the Space Show Tuesday evening West Coast program, and I'm your host, David Livingston. Thank you very much for tuning in. A couple of quick announcements before I introduce our guest, Dr. Casey Handmer. Hotel Mars is Rick Fisher tomorrow. He is going to detail Chinese astronaut rescue plans and more. Friday, we have an English science author, Brian Clegg, Clegg, and he wrote a very interesting book. So I decided to bring him on board. The Multiverse When One Universe Isn't Enough. Remember, he's an UK science writer and advisor. So if you want to join us, and I hope you do, be familiar with his book. Look him up on Amazon or Books a Million or something, so you at least know a little bit about what he wrote and what his arguments are. And Sunday is our last open lines program for 2025 of free discussion for everybody, including people who might want to use the telephone line and give us a call. Don't forget that we're in our annual fundraising campaign for new listeners and viewers to the Space Show. We're 100% listener supported, so we depend on you to support us. We are a 501c3 nonprofit, and we have our annual drive between Thanksgiving and the end of the year. And that's what funds us for the coming year. So if you like us, support us. And if you don't like us, then why are you tuning in? So, I mean, that would be a fundamental question, I guess. Um, so we also have sponsors. If you're interested, email me at drspace, DRSPACE, at thespaceshow.com. Dr. Casey Handmer is with us tonight. He was last on a little bit before the pandemic got into full swing, but he was over at JPL at that time. He has his PhD in theoretical physics from Caltech. Um, he was involved in GNSS science, Mars mapping, advanced tech development, and he has now formed Terraform Industries to make carbon-free synthetic gas from sunlight and air. His website is caseyhandmer.com. You will find there his blog and much of his writing and his opinions. He's prolific. I wish I had the energy and the wherewithal to write as much as Casey did, as Casey does. Casey, welcome back to the show. How are you?
I'm very well. It's good to be back.
Um, Lots to talk to you about. I guess I'll start off and say, in your opinion, are we going to be able to get back to the moon by whatever deadlines the government would like us to get back there with humans? What do you think of our plans to get back to the moon?
Yeah. Well, I think the deadline that really matters is whether or not we get to the moon before or after China is able to establish a temporary or permanent human presence there. And I think the moon is certainly big enough for both the United States and China. But I think if the United States is able to establish presence there, then we can probably continue to develop that in a mode similar to what we've currently done with international space cooperation worldwide. And I think it's far from guaranteed that China, at least under Xi Jinping, would see it the same way. China states that they want to do it by the end of 2029. So as of now, there's about 4 years to go. Seems like a long time, but it's 1,300 days or so. And if you were to extrapolate the progress of the current, official Artemis program, which is to say SLS, Orion, Gateway, and then some kind of human landing system to go from Gateway down to the moon, there's a very, very small chance that will occur ever, given infinite time, let alone before the end of 2029. So I would say that if we kind of proceed along that course, our odds are not good.
Have you had called to your attention or reviewed or looked at alternate ideas to go to the moon that would bypass some of the Artemis plans and infrastructure, but maybe get us there quicker, like simplified things instead of Starship with a lot of refueling, simplified landers, things of that nature? Are you up on any of the options that people talk about that they would like to implement to make us more competitive?
Yeah, I mean, I've written a number of blog posts on this subject, and I'm not the only person who's done so. I'd say like the key challenge with Project Artemis is that there's just a lot of complexity, a lot of parts. This is not a new problem actually. Back in the Apollo era, John Hubble was this engineer who wrote a memo saying like, do we want to go to the moon or not, and basically forced the down selection towards a lunar orbit rendezvous instead of direct descent, which meant in turn we were able to reduce the size of the Saturn V very slightly, and in turn increased its chances of success. And I think that it's really important that if you're trying to achieve something like this, that you focus on delivering only what you want. But actually, in your first question, you asked about congressional mandates and congressional deadlines and so on. And the reality is that none of the congresses who've funded Artemis to date have really done so in a way that makes it clear that like delivery must be obtained by a certain date. It's not exactly controversial. The people involved, in their own words, have said that they're much more interested in continuing funding for their particular parochial interests than they are in upholding, American strategic primacy in space indefinitely. That's also an important consideration, but it's maybe not the primary consideration. In terms of simplifications, I mean, there are a dime a dozen in terms of ideas floating around. Pretty much, anytime there's a changing of the guard, as there is, right now under the Trump administration, all the usual suspects who weren't selected last time around throw their hat back in the ring and say, pick me, pick me. And fair enough. That's their prerogative to do so. And if they have a better model for it, then by all means do so. And I think the current model is, yeah, sure, Boeing, Lockheed, Northrop Grumman, come to the party. But like Blue Origin and SpaceX, you're going to have to put a lot of your own skin in the game. You're going to actually have to show that you're willing to bet your own money that you're able to deliver, and not just kind of hand the check off to Uncle Sam indefinitely. Mike Griffin was circulating a paper just over a year ago, promoting an idea to basically take the Apollo era lunar lander, double it in size, so from 16 tons up to 32 tons, and then use that as a landing vehicle with expendable hydrazine-based propellant. So that's probably like the default like non-Starship use case. But I would personally say that like if you're really kind of looking around for things that are consuming a lot of time and budget and energy and not actually adding very much to the overall program, you could look no further than SLS, Orion, and Gateway is kind of unholy trinity of kind of interlocking failure, where SLS is just insanely low flight rate, insanely expensive, insanely unreliable. Orion, same story, talking billions and billions of dollars, maybe one or two of them ready in time. The heat shield and it's too heavy. And then so we have this Gateway to make up for the fact that it's too heavy. Like, come on, guys. The kind of the dirty secret of Project Artemis is that the actual landing system was such an afterthought, that in the end they handed out these contracts to SpaceX and then to Blue Origin to build a human landing system. But that human landing system won't launch on SLS, right? So if you're able to fly the whole damn spaceship to the moon and then back, right? If you can fly it you have to fly the spaceship from the factory on Earth where it's produced to the moon and then back to NRHO Lunar Gateway. There's absolutely no reason why you can't fly it from the factory on Earth all the way to the moon and then back to Earth without going to Gateway at all. And if you're not going to Gateway, then you can delete Gateway as well, and that saves a lot of time and money. And you can delete Orion because if the spaceship is going from Earth to the moon, then you can put people on it. And you can delete SLS because if you're launching the lunar lander without SLS, then why do you need SLS? Yeah, this seems obvious enough to my second grader back home. So I don't think this is particularly controversial. It does obviously gore a few sacred cows here and there, who are accustomed to receiving kind of free money indefinitely and not really delivering. So
So are you
You,
open to having your views challenged?
Casey, for any listeners that aren't aware, everyone should know that Casey does a blog that is definitely worth following and having a look at. In a recent blog post, you called it something like Orion is a flaming piece of garbage. I think was the title, and it contained an extensive list of grievances against Orion and SLS. Clearly it's a pretty flawed architecture for trying to get back to the moon. In your blog post, you I think you made the comment, why spend another dollar on this architecture and in particular Orion? I think what the question in my mind is the quickest way to get back to the moon is going to be some combination of stuff that's in the works now, and obviously Starship is the leading contender to get us back there. But it's behind, and it's also got these issues related to the refueling that are to be determined, but certainly will add to the cost of using Starship to get there. I guess I don't disagree with you that there are serious problems with Orion and SLS. I do sort of question whether turning off the spigot today is the right thing to do. Just thought maybe you might want to riff on that a little bit.
Well, I mean, it's my personal opinion, obviously. I don't represent anyone else. But
Sure.
in my world, which is privately funded hardware technology development, kind of equity funded off my balance sheet, right? Like, you have to choose. Like, are you going to continue to shovel $15-20 million a day into a project that's been failing for 20 years or not? Do you want to reward failure? And if so, how much? And I mean, the Apollo program itself, like, parallel tracked many different technologies, and when they down selected, they deleted the ones they weren't doing. And the people involved got well, thanks for coming. Sorry about this, but we actually have a mission here. We're trying to succeed. It's not about DEI space program, everyone gets a prize. At the end of the day, like, the contractors who are developing SLS and Orion have had 20 years to deliver value to the US taxpayer, and they haven't. They've basically stolen the money. And now it's a real problem because China's breathing down our neck, and they're saying, oh, well, it's too late to switch horses now. Give me a freaking break. Come on, guys. The amount of money that's being consumed by these projects is on the order of $4 or $5 billion per test flight. And meanwhile, NASA has managed to cough up $2 or $3 billion for each of the HLS programs. Are we serious people? We're seriously going to spend 95% of the budget on the rocket that doesn't fly, and 5% of the budget on the rocket that does fly? Come on.
Which is the rocket that does fly? You're not talking about Starship, are you?
Starship's had 11 test flights, and SLS has had one.
Yeah, and Starship hasn't gotten to orbit yet, so I'd say that's a big waste of money. Whereas,
Starship has
SLS got to orbit and beyond on the first try. So it's like clearly like it costs a lot of money, but this is where I think I would challenge you if you don't mind having your views challenged.
I mean, I'd have to say, like, I'm accustomed to hearing the canard that, like, a Starship has never gotten to orbit. But anyone who knows what they're talking about in space knows that's untrue. Starship has reached orbital velocity on multiple occasions, and yes, they've elected to shut their engines down like 3 seconds too soon, so that they are able to, like, kiss the atmosphere on the other side of the Earth. Like, their perigee is just below the edge of the atmosphere, so they can re-enter and land just off the coast of Australia. And that's just for, like,
they're short a fair bit of delta V. I mean, if you watch, like, Thunderfoot did a video just a couple days ago on this, where he showed that
Thunderfoot's an idiot.
He's not an
idiot.
He's not an idiot. No, he
doesn't know what he's talking about.
He did the calculations, or he got probably Gemini or something to do the calculations. But I've done these calculations. They're pretty clear. You need a certain amount of extra delta V to get to orbit. You got to circularize the orbit, and you got to get the perigee up to orbital altitude. So that extra delta V
calculations myself.
is similar to the payload that they could possibly carry. It's like the Starship doesn't have enough delta V to get to orbit yet, and that is something you can't argue with. Like,
I absolutely can't argue with that. I don't want to argue with it because it's not particularly interesting to the guests here.
Okay.
Like,
Well,
I mean, I just had dinner with my friend who's a SpaceX engineer. I think we know what we're talking about. Like, it's oh yeah, SpaceX. What would they know about launching rockets? Give me a freaking break. That's insulting. That's insulting to your audience to even suggest that Thunderfoot has something meaningful to say about rockets. That Thunderfoot, literally, like a counter signal. Everything he said about science and technology has been wrong for the last 10 years. I used to be a huge fan, to be honest. Like, I don't know, 10, 15 years ago, he was fabulous, especially in the new atheism stuff. Really funny guy. At some point, he lost the plot. He just lost the plot. And his work is lazy. And I think, like, audience capture took place. His work's lazy and derivative, and he doesn't know what he's talking about. You're telling me the Starship, which retained enough propellant to be able to come back and land on the ocean, soft landing on the ocean 3 or 4 times, didn't have enough propellant to circularize its orbit?
Yeah, that's right. I've done the calculations. I've done the calculations, and I'm positive that it doesn't have enough propellant and delta V to get all the way into orbit, circularize its orbit, drop off payload, and come down.
Okay, well, let me put it this way. Do you really think that SpaceX and all their engineers and Elon and the people who built the best rockets that, rocket motors anyone's ever built, and were the first people to refly, orbital class boosters and so on.
But so where
like
do they get the
somehow
best
like dropped a
rocket
digit on
engines
the
ever built?
spreadsheet.
Like you're saying they're better than RS-25? Like I think that's a better rocket engine.
Yes.
Where do you get
Are you
that
kidding
from?
me?
It's got much better ISP. Like RS-25's got much better ISP than Raptor or
It uses a
Merlin.
different propellant.
Yeah, that makes it a better engine.
No, it doesn't.
Sure it does.
Apples to
They
apples
get-
comparison. It
They're
has
getting more
lower,
delta V.
lower
They
pressure
get
pressure.
more delta V out of that engine than Raptor or Merlin ever will. And I'm not saying they're
Let
bad engines,
me-
but
Let
you
me
can't say
let
it's the
me
best
ask
engine
you
ever
a
built.
little question here. After test flight 13, which I think is going to be the double catch, which way does the rocket lean? I think test flight 13 will be orbital, and it probably will deliver, I'd guess, at least 10 version 3 Starlink units, and it comes back and lands. At that point, everything that says Starship can't do it pretty well falls away. Plus the fact they've landed the Starship, now they can go in and inspect every bloody tile and figure out which ones need to be modified to make them better.
When you say
can fly multiple times.
when you
So-
say Starship, that they have landed only the booster, not the upper stage. So the
No,
Starship
Marshall's
upper
talking about
stage.
after flight 13 when they attempt to recover it.
Well,
They
Okay,
intend
fine.
to
But-
Like
recover on-
we can't predict the future. What I'll suggest is, let's say a hypothetical situation. You think I'm too harsh on SLS and Orion? Maybe I am. That's fine. I have a pretty high standard when it comes to these things. I say, okay, fine. We'll agree to this in principle. Let's say that SpaceX demonstrates orbital refilling. That day, can we now cancel SLS and Orion? Right. Starship has demonstrated orbital refilling.
No.
Maybe next year, maybe the year after. At
No,
that point, can we
no.
stop pouring $20 million? No. The people who support this program will come up with yet another excuse. They'll move the goalposts yet again. They'll say, no, we absolutely must continue spending $4 or $5 billion a year in these key congressional districts, no matter what, forever and ever. Amen. And this is so it's always moving the goalposts.
So how
Well,
about
we
how
are-
about
we
we
are-
clarify
we
the
are not
question here?
talking about-
Wait, let me jump in here. If we want to get orbital refilling, are you going to say if they can demonstrate orbital refilling with 100 tons of propellant transferred to another vehicle every launch? Is that what you're saying? Because if they can do that, then they've achieved the goal that NASA signed up for. If they transfer like 30 tons of propellant, then it's ridiculous. They'd have to launch like probably 50 Starships to get to the moon. That's just a ridiculous plan. So if you're talking 100 tons plus of propellant, like Elon proposes, and you're saying that's where the goalpost is, I would say sure. If they can actually do that, then we should consider canceling SLS.
Then
if
we
they
should
can meet all
consider
the-
canceling SLS. That's very generous of you.
if they can meet all the safety
Oh.
constraints and stuff like that, sure.
That's
We
right.
can
Yeah,
meet
I
safety
think
constraints as well.
You got to
Don't-
look at the
don't
cost of
apply to
like
SLS
all
and
those
Orion.
launches, right? Like every time
The
you launch,
SLS and Orion, the safety constraints don't apply to them.
yeah, they're meeting the safety constraints though, right? Like
No, they're
Starship has to come back in over land and land, like do a tower catch after coming across the
The
continent of
SLS
the US.
booster rocket,
That's
the
scary.
solid fuel booster rocket, has failed in critical tests twice in the last 2 years. The SLS Green Run test failed for reasons no one could even explain for 3 days.
The SLS Green Run
Orion-
test.
Yes,
But these are
In
just
the-
ground tests you're talking about.
it was the first full up static fire of the SLS.
Sure, but these
Yeah,
are
it's
ground
the
tests.
ground
These are
test,
like
yeah.
you're supposed to fail things at the ground test level. Like
No, you're not.
SpaceX
You're
does
not
this
meant to.
regularly. You can't go and say if SLS has a failed ground test, that makes them worse than Starship because or SpaceX. SpaceX has thousands of failed ground tests. I mean, all the time. That's part of their whole paradigm is let's have lots of failed ground tests and then have failed atmospheric tests and failed real tests as well. Like
It's going
failing
to be
tests
then-
is not the
because
grim.
Starship is not
And-
run as a cost plus project.
Okay,
Starship
yeah,
is
we cut
primarily
off,
privately funded.
We got a
And
AJ,
you
so
are-
let AJ jump in.
you are poo-pooing the fact that it will require anywhere from 10 to 25 refuelings. And each refueling, if you give it 0.98 success rate, for which you still, at least at this point in time, you cannot. You multiply that by or take the exponent of 10 or 14 or 15, that brings you down to 0.74 success rate. That is really ridiculous. That is ridiculous to say that that is what we will rely on. That was really just for one trip to the moon, that will rely on that kind of a thing. And also, the other thing that I've been pointing out in the past also is that their Well, let you answer this, and then I'll point out the other one.
Mhm.
Well, I mean, if we follow your line of argument, we should never bother to build the Starlink constellation because there's a 0.2% chance or something that one of the Falcon launches will fail and the satellites will burn up, right?
No.
And that they're completely irreplaceable.
That's not the same thing as refueling the depot at the same place that you're going to have to refuel, connect them, and refuel them. That's not the same thing. It's
Why is
absolutely
it
not the same thing.
Right?
What?
Like how is fuel that you're transporting from a tanker? How is fuel that you're transporting from a tanker to some orbital depot somehow less fungible than Starlink satellites? They're both mass
Well, of
produced.
course it is, because you have to connect them together, make sure that they are connected, and make sure that the cryogenic propellant can transfer from one to the other safely all the time. If one of them fails and the depot is, let's say you do 10 successful refueling, and then the 11th one comes and doesn't do a good job, or hits it, or some other stuff happens, then the whole thing goes off in flames.
Yeah, it's true. Orbital docking is non-trivial, which is why Buzz Aldrin did his PhD on it, and then they spent the Gemini program learning how to do it, and we've known how to do it for 60
I'm not
years.
talking about orbital docking. Orbital docking is still been done many, many times by ISS. I'm talking about orbital docking for refueling. Refueling,
It's
that's
done on the ISS. It was
quite
done on
different.
Mir. It was done in Salyut 7. I don't know what you're talking about. This is not a complicated thing. Compared to landing
Is it a
booster,
matter?
pushing
Is it
on a
just a
tower,
matter of timing? Is it just a matter of timing? Because I think the probabilities of launch success that AJ is talking about is something that's going to improve over time, so that in the long run, it's probably a non-issue. But in the short run, and that's what we're
timing's a major
talking
issue with
about.
the default Artemis program because it calls for the HLS lander to be able to loiter at NRHO with the gateway for up to 3 months, because they recognize that SLS and Orion's launch could easily be delayed by 3 months, right? So there's shoddy underperformance of the primary system forcing a bunch of marginal requirements downstream, right? And you're saying well, that's an acceptable compromise to accept, right? But the idea that we might lose a tanker and therefore we'd have to get another tanker out of the Starship factory that produces 250 cores a year, and that's going to be a real challenge. Give me a break.
I mean, I'm not talking about losing a tanker. I'm talking about losing a tanker when disconnected to the depot.
The thing that these people don't understand is that for SpaceX and Starship, the moon base is a side quest, right? It's a thing that you do when you're not doing the Mars thing. The Starship is built to move 1 million tons of cargo to Mars. And so doing anything related to the moon is trivial by comparison. It's so much easier. It's so much easier. And so you've got to have this system that's massively overspec'd, massively overpowered for doing anything related to the moon. And you can say, well, what if we can only lift 80 tons instead of 100 tons of propellant the first time we try? Well, I don't know, but maybe by the time they've built the 20th tanker, they'll have figured out how to reduce the mass fraction a bit, right? But if you're talking about the SLS, when they're making one core every 2 years, they'll never get to the 20th thing. Literally everyone involved in this call, including me, will have died of old age by the time we get to that point. So it's a completely different paradigm. Here's the thing: you can actually just drive down to Texas. Any of these people can jump in a car. You can drive down to Texas, and you can look over the fence at what they're doing at Starbase. You can see with your own eyes what's going on. It is absolutely mind blowing. You absolutely have to do it. It will change the way you see the world. It is completely insane. It is. I go there every year just to break my brain a bit. It's absolutely mind blowing what's going on, and it's just not well understood. These people are operating on a different level. They're operating with a kind of different set of rules, solving a different class of problems in a different style. It's completely different. The Orion program is a program that has struggled to engineer a door that will seal for 7 years. 7 years. God knows how many tens of millions of dollars they've spent in NRE trying to copy paste a door from the Apollo capsule onto the Orion capsule, and they still can't make it work, right? That is not possible at SpaceX. No one could do that at SpaceX because you'd be fired instantly. It makes a huge difference.
I would like to ask a question. How big of an issue is boil off at the fueling station? Is that the key that says how many trips have to be to fill up the tanker? And then as Starship goes to the moon, is there any significant boil off there? Because usually they never say anything about in transit, just in
Well,
orbit.
there's no significant for methane and LOX. There is a huge boil-off issue for liquid hydrogen, which is what Blue has. So that is not really a big problem. If you look at the numbers of a percent that can boil off per day, and then you multiply that by the number of weeks or days or something, it really is not a very big deal. Although, the LOX also can boil off. It's at, minus about 220 degrees Kelvin. So it can still boil off, but it's not a big issue. Nothing like hydrogen, which is what Blue has. That is what sort of is a problem with Mark II and Mark I, both of them. And by the way, I just talked with Mike Griffin just an hour ago. And just for your information, he's going to be giving a briefing to science committee in the House on Thursday. So you might want to watch it.
Oh, very good. I mean, that's an issue that Mike and I have discussed in the past regarding boil off. And then I went and did a bunch of math on it to see whether it be an unsolvable problem. And again, like SpaceX has not invested, as far as I know, significant resources into solving boil off, but it's something that would need to be solved for the Mars mission. So I looked into the math, and you basically run a refrigeration loop. You can run autogenous refrigeration on both sides through radiators with like a couple of tens of kilowatts. It's not a huge amount of power in the grand, and that's for full scale Starship, fully fueled. Not a huge issue in the grand scheme of things. Part of the reason that it's not such a huge issue, especially in deep space, is that most of the heat comes from one source. So you can have some MLI shielding in that direction, and then radiators obviously on the opposite side. And then the Starship itself is really huge. So you've got this square cube thing in your favor. That said, long duration propellant storage for even hydrogen has been demonstrated successfully by ULA. It's been successfully demonstrated by Roscosmos, and now Blue Origin has an autogenous refrigeration system for the hydrogen as well, so they can stay on the moon. So it's like in the grand scheme of things, you're like, oh no, we need a better refrigerator is a very nice problem to have.
Thank you.
My problem with Starship and my feeling and my calculations show that, that it just really is too big for the moon. It should have been about 1/3 the size. And actually, what I've done is to do a lot of calculations. And I'm very much in support of Elon in terms of Falcon 9 and Falcon Heavy. And with Falcon Heavy, you can put people on the moon in a short period of time, short amount of time, much quicker than Starship would be able to. Several flights of Falcon Heavy would be needed, but all you do is dock the upper stage in space. You don't refuel, and the upper stage of Falcon Heavy is only like 6 tons each. So you can take that to the moon along with the payload. With the 2 flights, you can take a 20 or 30 ton of payload to the surface of the moon and land there. So that would be
if you wanted to refly Apollo, you could do it with 2 Falcon Heavies, Dragon and a lander. And in fact, if you were like, gun to your head, simplify Artemis right now, you could replace SLS and Orion with Falcon or Falcon Heavy and Dragon. And
that's right. Yes,
I've never met anyone who's seriously involved in this thing that thinks that would be more dangerous or more expensive. It's true the Falcon Heavy has not been human rated, but it's
Falcon 9 has been human rated many times. So Falcon 9 has been the same thing.
It's similar. It's similar. I think it would be easier to wave your pen in that direction than to justify SLS. Frankly, the SLS solar boosters are about 1 in 100 chance of exploding or doing the wrong thing. Bad news. I don't know. Like, here's the thing. Right now, there's this big kind of to do about whether or not Artemis 2 will fly, and it will fly 4 astronauts in Orion around the moon and back. Supposedly like March or April next year. And it's kind of a refly of Apollo 8, but not really, because in Apollo 8, they went into lunar orbit for a while, almost a day. And actually, Orion can never enter low lunar orbit. It's too heavy. So you say, well, you could do something like that. It would be a bit like Soyuz 11, right? Like you're basically cramming 3 men in the can in Soyuz 11 just to show that you could, and be the first entity to launch 3 people into space. But in order to do that, they had to cut some corners, and including flight suits. And as a result, after the successful 2-week flight, on the way down, they suffocated. And I think that statistically speaking, the chance of the astronauts surviving Artemis 2 on SLS and Orion is probably like 85, 90%. Like, it's like better than even odds. Like roughly the same odds of success at a first time unassisted childbirth, something like that. But I also feel like the United States has grown beyond the point where it would pull a stunt like that in the hope of, like, sticking our finger in China's eye, because the risk is just too high. Like, sure, the astronauts explode or suffocate or something and die. Like, that's a really bad look. Everyone looks really bad. Everyone feels bad about it. No one can really say that there was no chance it could have happened. There was such a shock, like they did after Challenger, right? But like, let's say they get back, and then it becomes obvious that, like, the heat shield burned through, and, like, 1 minute either way, and they would have died. Like, that looks even worse, right? Like, why the hell should the United States be an organization that, like, puts straight SpaceX and Boeing through the ringer for their crude commercial launch to the space station for like a decade, and then goes and, like, makes this insane crazy risk on their own home built rocket, and then just for, like, basically no reason. Like, if you want to fly humans around the moon, strap them to a Falcon Heavy. You could fly Falcon Heavy, can fly people and Dragon around the moon. There was even a program to do that
I'm
for a
going to
while.
challenge you on that one. So why do you think the Dragon can come back from the moon and make a re-entry without burning up? I mean, it's not designed for that. It's designed to come down from low Earth orbit.
It was designed to come back from hyperbolic trajectories. The heat shield is spec to do that, and it uses Pico-X, a heat shield which is proven to be much more robust than the Avcoat that's used in the.
You think the Dragon was designed to come back from hyperbolic trajectory, like from the moon? I've never heard that. Or where did you hear that?
It was.
Never heard that. Yeah.
Elon told me once.
Elon told you once.
But, like, it's not controversial. You can look up, like, was it Red Dragon or whatever? It talks about bringing Dragon to and from Mars.
Casey, I want to move a little bit off of this discussion
Yeah, I think we should
because
beat
it's
this one
a
to death.
little bit too much in the weeds. But before everybody starts jumping in and jumping on me and talking at once, uh, the facts on the ground are that we have a program approved by multiple Congresses and multiple presidents, and it is a program of record. And there is a critical time period here because it takes a lot of time to do things in aerospace and engineering and design and manufacturing. So 3 years really isn't a lot of time to put architecture together and to do a lot. And so people within the industry, and this is not the only show that talks about it, kind of have a sense that if you really want to get to the moon, this is not the way to do it. However, in terms of the fact that this is a government policy, it's a program of record, it's set, and that there isn't any official push to modernize or change the program of record. All of this quantitative stuff that you guys have spent 35 minutes talking about, the fact is nobody really gives a shit. Half the people in Congress wouldn't know what you're talking about if you went before their committees and gave them a presentation on what Phil was saying or what you had been saying or AJ was saying. Probably most of their staffers wouldn't pick it up. I don't know what would happen in the upper echelons of NASA. I don't know what would happen in a Senate Tech Committee or a House Science and Space Committee. But the reality on the ground is you got a program of record that a lot of people in the industry don't think is going to work. And you got a congressionally approved program and funded. And what do you do about it? You can't go in there and have this big debate on whether Starship can do this or SLS can do this and the mass ratio is this and the this is that. They're not even going to hear you. So the question I have is more of a policy program here because I'm on the side where I do not believe the current Artemis structure will get us to the moon before China. I am also of the opinion that China may really enjoy sticking it to this president and put people on the moon much earlier than what they say their stated goal is, just to say, the president helped make China great, something like that. That wouldn't surprise me a bit. But how do you change the I don't even know how to ask the question. You have to change a government program, and maybe the program overall umbrella and infrastructure doesn't change. We're going back to the moon. We're doing this and this, but you got to change all the guts of the program, because the guts of the program aren't going to do the job, and you're not going to win people over with all of your theory and your physics and your math and your this or that and your other. You're talking basically to qualitative people, and even then, if you look at some of the people in Congress that you're going to need votes from, I'm not sure what they would understand or grasp. Okay, so how do you do it, Casey? What's the methodology to give us a winning program that works to go back to the moon without getting into the weeds of this rocket needs this fuel, needs this mass, needs this or that or the other? That'll fall into place if we had the plan to do it. We don't even have a NASA administrator yet. Maybe we will by the end of the year. But do you know what the NASA administrator wants to do about
We'll
all
we'll
this?
we'll have
I
him
mean,
by 8th of December.
yeah, but that's when his hearing is. It's not necessarily
Hearing
when
is
he's
tomorrow.
actually. Well, so
Here's tomorrow. Yeah.
do you know
Um,
what he wants to do about changing Artemis or letting it fly or believing what Starship says it can do or believing what Blue can
yeah.
do? I mean, what's the policy side of this, of how you make a viable program out of a program that's not viable?
It's a really tough problem, and I think part of the issue is that the highest level within NASA, who's like technically competent to speak on this, would not, you know, see it as their role to advocate on the Hill for like what's technically possible. They're much more likely to accept the program as written and then attempt to execute within that
Who
sandbox.
is the most
And as
technically competent
well,
person at NASA?
that's a good question. But as John Hubolt said, like at the end of the day, maybe you can afford to be like a little bit inefficient when it comes to capital allocation for a new aircraft carrier program or something. But for flying to the moon and back, like there's not a whole lot of wiggle room
No
to
margin wiggle room there.
yeah, exactly to do it wrong. But I think that like everyone in Congress wants to succeed, right? I don't think anyone in Congress is like, oh, wouldn't it be great if we were standing here when China got on the moon first, and then we were asked questions about like why the hell that happened. And I think they understand that like, a lot of the new space stuff that's happening is actually very charismatic, and a lot of people are very engaged with it. Particularly in the more space adjacent states or something like that. But it employs a lot of people across the country. A lot of kids grow up in school dreaming of being astronauts or engineers or whatever. I think it's a very charismatic program overall. As for what Jared would do if he was confirmed, I mean, we'll let him speak for himself. But I think the really interesting thing about Jared is that he's actually run a successful private organization for many years, and so he has a pretty good intuitive sense for like what success looks and feels like, and that's actually, it's not unheard of, but it's relatively rare in the public sector. And so I think that that instinct, that intuition is actually very undervalued. I think that we're kind of unbelievably lucky that someone of Jared's caliber and interest has taken an interest in this particular job, because ordinarily it would not be something that's on the path for someone in that walk of life, I think.
So how are they going to change how they do it? They're going to call in Phil. They're going to call in AJ. Are they going to give you a phone line and say, Casey, come back and
Well, I mean,
help us?
I think my perspective on this is, sure, like if Starship never flies ever again, then like fine, whatever. Like it's not my program. But Blue Origin has made some good progress recently as well. And I think that once Blue Origin puts Mark 1.5 or whatever on the moon next year unmanned, and Starship does the double catch and some fuel transfer and so on, that like either Congress is going to get on the train or they're not. But like SpaceX can quite easily complete the HLS contract as written within the current law, and then it's Congress's decision or NASA administrators' decision if they're like, well, Orion's still not quite ready to go, but HLS is. Maybe we should just fly with HLS. Maybe we can order things. There's kind of a debate that's occurring right now generally as far as executive power goes, which is like, to what extent does the executive branch have to spend money that is appropriated and authorized by Congress? And over the last 30 or 40 or 50 years, it's been considered mandatory, but there's a legal discussion about that. So I don't really know how it gets sorted out, but I do know that the key people involved are absolutely determined to see success occur. How it occurs is maybe not something that they lose sleep worrying about, in terms of delta V's and precise orbits and so on. But this is much the same as the Apollo program. I mean, like, Kennedy was not a rocket scientist, and yet he understood that, like, you need to get the right people in the right place and make the right decisions, and they ultimately got there in time and managed to pull it off. Absolutely extraordinary achievement. There's actually kind of a general issue here, I guess, which is like, Congress has the power of the purse, but they're not necessarily particularly technical in general. Most of them are lawyers. So when it comes to technical programs, how do they successfully go to the might and the power of U.S. industry and say, well, we need to get this done. Can you please help us out? And I think that NASA's, like, I've written some blog posts about this, not exactly like secret. This is my perspective, but like, it is unfortunate and also true that NASA's ability to have this kind of operational and programmatic like integrity or like execution capacity has really fallen off over the last however many years. And it's a problem. It wasn't a problem in the past because it didn't matter all that much to anyone, right? Except for the people involved in it. But it's a problem now. It's a problem now because NASA's mission is like uphold US freedom in space forever. And it's looking like they might not be able to do that. So, like, if you can't do that, why does NASA exist?
May I point out that during the Apollo, we were in a space race with Russia. So I think half of getting Congress to get out of the way and the bureaucrats out of the way is a heavy dose of embarrassment. Have the Chinese go up and orbit the moon a little bit. All of a sudden, a lot of problems go away because nobody wants to be blamed for slowing things down. And what's the moon race factor?
Yeah, I mean, it's well, one would hope it doesn't come to that, right? Or tragedy, right? But we've seen some squeakers at some narrow escapes at NASA in the past, and it's never quite big enough to dominate the news cycle for long enough for anyone to do anything about it. I think that's actually kind of a major change since maybe Columbia or something, or Challenger, which is the news cycle has gotten really fast. And so I could just as easily imagine a situation where China lands on the moon and says it's ours now, and we're violating, or we're no longer, we're renouncing parts of the Outer Space Treaty, and we're keeping anything below 80 degrees south on the moon is ours. Don't go here, or we'll nuke you. That's tough, and we lose it forever. And the response by the US political class is don't look up. It's like, oh, well, whatever. It's just boring, useless rock. We'll just continue doing whatever we're doing down here. Just ignore it. Much as I think the United States is pretty good at looking the other way when they don't want to.
Well, if China gets on the moon, though, they can't stop us from just ignoring them and going up there anyhow. So, I mean,
unless they shoot at us.
Well, then we'll have to have something that can shoot at them. But I mean, I don't think they'll have any real military capability on the first flight or the 10th flight. I mean, it'll take a while to develop that.
Yeah, and also Aitken Basin is about 2,000 kilometers across. And if China goes and lands and claims, let's say, 100 kilometers square or 100 by 100 kilometers square, there's still plenty of land, plenty of moon surface left for us to go, and they cannot stop us.
Well, I would like to think that's the case, but China has, of the permanent members of the UN Security Council, China and Russia are kind of displaying untoward levels of extraterritorial ambition. China's in the news every other week, sending their coastal navy to harass fishing boats off the coast of the Philippines, 1,000 miles from the EEZ. These are not people who necessarily see, and I'm not talking about the Chinese people in particular, but like the particular shards of the ruling faction. They don't necessarily see eye to eye with us as far as common use of celestial property or whatever. And it doesn't help, I suppose, that the Congress decided to shut China out of the ISS for whatever reason. But I mean, like the vision of the future that I think we can all agree that we want is one where where come Thanksgiving, all the astronauts get together at the giant South Pole base and share a turkey and have a good chat and have a bit of a drink and a good laugh, right? And not one where they're pointing guns at each other. And yet, the way to ensure that that's the case is that we need to make sure that basically American hegemony is projected into space. And NASA was formed in 1958 in response to Sputnik, along with DARPA, and its mission was, make sure that we own the high ground. And they did a good job of that for a while, and then kind of got distracted here and there. And it's no longer the case that I don't think anyone really doubts that the United States can't put an aircraft carrier somewhere and then start bombing people, right? Like there's not really a doubt that the U.S. military has the strongest military force the world has ever known. But there is a real doubt that actually, if NASA is able to deliver on its promises and its charter to uphold U.S. interests in space forever, and that's something that actually does keep me up at night.
Mm-hmm.
On Halloween, which was October 31st, you called the Orion space capsule flaming garbage in one of your blog articles. So did you get any blowback from that? And where did the blowback come from? Did you get blowback from any identifiable NASA or aerospace companies? I'm curious, given that kind of headline, what you got from it.
It was definitely a Halloween-worthy blog post, and I did want to get it out before Halloween because aspects of the story are rather macabre. Like no one really wants to be there, like scraping the remains of the astronauts off the seat, like they had to do with Soyuz 1 after the parachute failed, right? So yeah, it's a somewhat sobering thing. No, in answer to your question, one of the great things about writing a blog that people read and had about 100,000 impressions on that blog is that if I make a mistake, people let me know straight away, and they do so in good faith almost always, and I go and edit it. And if you look at the comment history, you'll see that probably put in a dozen or so edits in the first couple of days just to like fix typographical errors and other things that I'd noticed that were wrong. But actually, overwhelmingly, the feedback is always positive. Overwhelmingly, as I said in the blog post, and I wasn't making it up, the people who are even working on these programs say, yeah, I'm so glad you wrote that because I couldn't do it, or I wouldn't do it. I wouldn't know how. And but I felt this way for a long, long time, and I'm just sick of showing up to work every day and pushing paper around and pretending like we're doing real work. And obviously, people who don't feel that way are probably not writing the email saying that. I'm sure that there are some people there who don't feel that way, but I'm pretty careful as well when I'm writing these blog posts that I'm mostly quoting from the OIG, right? I'm mostly quoting from NASA's own internal watchdogs on these subjects. I'm not just making stuff up, right? I'm actually just kind of collating the information in one place and showing how it fits together, and then pointing indicatively towards other historical failures of NASA and other agencies and saying, look, there's a common thread here. It turns out that if you prioritize things other than technical integrity, sooner or later you're going to ash some astronauts. And NASA's lost 17 astronauts in flight or flight-related accidents. They didn't want to lose any, and yet they acted in a way that made the loss more or less inevitable. So if wishes, were ponies, we'd all have one, but they're not. And if I don't think anyone can really say that like the 17 astronauts that NASA lost were kind of lost for a good reason, right? Like I think if like the Apollo 13 astronauts had died, we'd be like, damn, that was unlucky, but they got very close, right? And they could have easily died, like a couple of hours either way, and they would have died in terms of when the accident occurred.
Do you think that
you look at how the Columbia 7 died, and you're like, that was just stupid. And you look at how the Challenger 7 died, and you're like, that was stupid. And you look at how the Apollo 1 people died, and you're like, that was stupid. They didn't push the bounds of human imagination. They weren't, it wasn't some heroics. They weren't trying to save other people. It was just like a problem that everyone knew had been a problem for a very, very long time finally blew up.
Do you think we need like an office of the Inspector General for SpaceX and Blue Origin as well? Like all these commercial contractors seem to have lacking oversight to make sure their statements are honest. I
mean, arguably OIG, like NASA's OIG and FAA and so on, can get involved on the program supported by these contractors, just as they do with Boeing and Lockheed, for the programs that NASA funds, obviously. I don't think there's any reason to have a NASA's OIG or anyone else get involved in, say, the Starlink business that's privately owned and operated. But it is obviously heavily regulated by the FAA and FCC and so on and so forth. I think there's a long line of fairly dubious public statements from NASA's various contractors, and I think that the top of that list would probably be ULA's various chart crimes, followed by Lockheed and Boeing spending taxpayer dollars to propagandize the public about, misrepresenting factual statements about how SLS and Orion work, or in fact don't. And so as a result, I think it's very unlikely that this will go into place. Those people have good friends and they're well established, for better or for worse. But I think people like you and I, people who've been around for a while, they can see through this stuff. Yeah.
Well, I see the same problems with SpaceX. You don't seem to see the problems with SpaceX, but
what can you give me an example of a particular case you see in SpaceX's case?
well, like SpaceX, Elon Musk will get up and say that with non-reusable Starship can launch 400 tons into orbit, which is so ridiculous that I have to laugh. But he says that, makes that statement. He also, of course, says it makes every Starship that's ever been made will launch 100 tons in orbit, and of course, then he comes back a couple of years later and says it launched 15 tons or 30 tons, but it never launches anything. And these are statements I feel like the OIG would be able to publish something that says we did some real math, we talked to real engineers, and we calculated all the weights, and we have an absolute understanding of the performance of this vehicle. And this is a number we come up with, and we'd have a real number. But
yeah, so if
instead, we're
SpaceX
just
is publicly
arguing.
traded, right, and
Yeah.
they made statements like that in connection with fundraising, then the various agencies associated with
this is
securities law would get involved. But but I think if you dig into the details, and you actually pay attention, not the sound bites, but you actually listen to the whole talk, what do you say is Elon will say, well, version 3, we expect version 3 to ultimately be able to reach 100 tons or 150 tons reusable to orbit, right? And so if you say, well, you expect the first test flight to reach 150 tons, that's a bit unrealistic. But I think that of all the different hard tech entrepreneurs out there, or technical leaders in general, I would say that Elon's statements have usually proven to be optimistic but ultimately true. And and I say that, I'm talking my book here. I've been long Tesla for 14 years, and they've been talking about full self-driving for a long time, and that it's essentially operational now, which is pretty neat. But it was a lot of hard work to get there.
I feel like Thunderfoot is the best OIG we've got for SpaceX right now, and you don't trust him, which is not unreasonable because he's not funded like the OIG would be.
Well, actually, IG did analysis of refueling, how many refuelings will be needed, and SpaceX number was about 8 to 10 to 12. IG's number was 16, and NASA's number itself was 20 refuelings. So IG has gotten into it a little bit, in that way, but they obviously have to, to be able to come up with this number.
Yeah, it's a tricky situation.
Hello?
Yeah, I'm just trying to think about how I can kind of couch this in a way that is more receivable perhaps by a general audience. It is often surprising the degree to which authoritativeness decays away from the nexus of particular technology development. And so the number of people on Earth who are qualified to actually give a X plus or minus 2 refuelings per Starship launch is a very small number, right? SpaceX employs thousands and thousands of people on the Starship program, but the actual number of people that I know of on Earth who I would trust to actually be able to do that calculation and get it right would be fewer than 10, right? Which means that the odds of the people at IG or at JSC or Marshall or whoever who are kind of looking over the fence and then coming up with a number that I'm sure just coincidentally happens to support their particular worldview, which is that SpaceX should be cut out of HLS immediately. The odds that those people happen to be sufficiently equipped to make that calculation and then sufficiently uncompromised to give it correctly is unfortunately pretty low. Which is to say that most of the rank and file at NASA and SpaceX have more in common with our Congress people than they do with the people who are actually making these particular high level performance calculations. Yeah, that's just the nature of the beast. But I think with Gemini and friends or Grok or whatever, you can probably get pretty close to those calculations. Most
you don't really
we actually did
require.
that in the show a while ago. It didn't work out so well.
May I ask, what kind of computer systems are they using to make these estimates with? Now, I'm positive the people at SpaceX with, I think it was called Dojo, and now it's Colossus 1 and Colossus 2, have complete engineering drawings, know everything down to a very small detail, and just somebody looking over the fence, I don't think is qualified because they haven't got the software to back up their estimates. What do you think about that?
I mean, rocket equation.
Dojo is Tesla's computer, and Colossus is XAI's computer. Colossus is actually arguably one of the largest computers ever built. By flops alone, it's 100 times more powerful than the most powerful kind of supercomputers prior to the AI generation, which is pretty exciting. You don't need a computer anywhere near that powerful to perform these calculations. I can perform them on my laptop.
Yeah,
it's mostly
it's
just
very
knowing how to write
simple.
the algorithms.
It's very simple. I mean, all you need is basically the dry weight of the upper stage, the Starship stage, which can be anywhere from 85 to 100 tons. And you need the delta V required to go there, and you know what kind of propellant you're going to use to come up with the propellant fraction. It's very, you know, it's very simple in that way that one can come up with those numbers cannot change whether you're using Colossus computer or something simple. I mean, that's just, you know.
I mean, you need a trajectory calculation, right? If you want to dial into a couple of % accuracy, you need a full trajectory calculation to take into account drag and lift for the upper stage.
Yeah, but you don't need to. You don't need to get within 1 or 2% accuracy for something when we are talking about 10 or 20 refuelings. You know,
the Starship, if it's lucky, might deliver something at 4% of its launch mass to orbit, right? Most rockets are more like 2%, 1 or 2% of its launch mass to orbit. So actually, the percents kind of do matter in the final analysis. And that's probably how you would account for something like, well, NASA says 20 and SpaceX says 10, right? Like SpaceX probably knows more about squeezing performance out of the upper stage than pretty much anyone else because they've done it 500 times.
You take the Starship number from SpaceX. I mean, and I took those numbers from SpaceX, which is 85 or 100 ton, and the total gross weight is 1,200 ton. Those are just numbers from them. You know,
you don't need to completely. Well, actually, it depends on what the final dry weight of the lunar Starship turns out to be, but you might not need to completely refuel it. You might not need to fill it all the way up. If you do, you could actually fly a lunar Starship from low Earth orbit to the moon and then back to low Earth orbit, which is a pretty neat trick. But you know, if you're flying the HLS trajectory, then you don't need to bring the Starship back to Earth.
that's right. Yeah,
To talk about the alternatives to Starship for HLS. The Mark 1.5. I mean, I assume when we say Mark 1.5, we're talking about the Mark 1 that's made like human rated. Is that what you're talking about when you say Mark 1.5? And do you know, is there any active effort to make that happen right now?
I don't know very much about Blue Origin. They run a tight ship, but no, I mean, Eric Berger wrote some article about a month ago saying that like Blue Origin is thinking of kind of an intermediate human rated lander, a bit more than Blue Moon Mark 1 and somewhat less than the HLS version, which is much larger. And that might be the fast track, right? That might be something like Griffin's 30-ton lander, except hydrogen rather than hypergolics.
That's right. Yeah.
And yeah, me and the usual suspects on space Twitter like ran the numbers on this, and it didn't seem to be like an obvious slam dunk. And the reason for that is that you know, either you have the capability to launch like a very high delta V service module plus lander into low lunar orbit, or you don't. And if you don't, then you know, you still have to spend an awful lot of fuel to get out there. So it might be the case that for example, you need a New Glenn to launch this into low Earth orbit fully fueled, and then another New Glenn to launch a you know, a high delta V upper stage to like boost it the rest of the way or something like that. It's all, unfortunately, all these, in my opinion, all these architectures are very pathological. They're kind of compromised in some sense by the original sin of the kind of the way that the what has become the Artemis program was kind of put back together in the early days of the Obama administration, where they basically deleted all the components of the SLS and Orion that would have enabled high performance long term. Yeah, and Lockheed's own manager, in his own words, in 2013, said this is crazy. Why are we doing it this way? And that's 12 years later, and we're still doing it that way.
Just a piece of data point. Mark 1.5 is supposed to have 3,000 pound, 3,000 kilogram payload, 3-ton payload, and 4 passengers on it. So, you know, along with that, probably is more like 10-ton payload for Mark 1.5. Mark 2 is 16 or 18-ton payload. And Mark 1, of course, you know, is 3-ton payload.
Thanks.
Yeah, I don't know. I mean, I suspect at this point it's mostly a spreadsheet.
Casey, I'd like to move you to Mars. We don't
I know
get
some people probably want to, yeah, without a spacesuit.
we don't get to spend a lot of time on Mars. Nobody
Actually,
wants to talk about
I'm
Mars.
wearing my Mars helicopter T-shirt today.
So now you see. So, in your opinion, what's feasible for us in humans to Mars and maybe Mars settlement? I mean, are we talking about science fiction still, or is it now in sight? In your humble opinion?
It's a little bit like one of those things where like the rabbit hops closer to the wall, but half the distance each time. So I'd say, like, compared to 5 years ago when Starship was basically a dream, like just this idea, we're obviously much closer. The various pieces are in place. And I think orbital refueling being done and maybe some test landings or test flights and stuff, but much closer. But like, even if by say 2030, we have the ability to land starships on Mars, that's been demonstrated. Maybe even say by 2035. Let's say we've landed 4 starships on Mars by 2035. You're still at the very beginning, right? You still have to get another 10,000 starships or so there to do anything, like, as far as the self-sustaining city goes. And it kind of requires like a major step change in terms of productivity and pace of progress at SpaceX. I know the people working there, they're working crazy hard and they're very, very smart. But at the same time, it's 2020, it's almost 2026. They've been at it for a while, and it's never gone quite as fast as they would have hoped. So we'll have to see. I think everyone involved should be eating their vegetables and exercising, because it could take a bit longer than we thought. But it is possible. It's certainly something that's within the realm of the possible. Is not forbidden by the laws of physics. It is the sort of thing that we can do with technology that we have available today. I think it was probably pretty ambitious to say we could have done it in 1985, but in 2025, I think it's well within our powers. The major, the kind of the exciting questions that I think a lot about, and it's kind of related a bit to the work I do here at Terraform, is how do you actually build a self-sustaining city with only 1 million people? Like, what stuff do you bring, and in what order, and who do you hire, and how do you have them live there, and what do they do? There's actually not a whole lot of academic research on this front, and not much in the way of successful real life case studies. If anything, the last couple of generations is the history of like what might have been previously relatively self-sufficient smaller communities, largely losing that self-sufficiency in favor of importation from much larger centers of production. So it's a bit of a pickle, bit of a puzzle.
With the technology we have today, can we handle life support for going to Mars and staying there?
Yeah, that's not difficult. We've had nuclear submarines for since 1955, right? And they've basically had the ability to run closed loop life support systems indefinitely. Actually, the limiting factor for nuclear submarines is food supply. After I think they generally run 3-month sorties, like 3-month rotations. But right. I think in history they've done the odd 6-month one. Yeah.
Do we need nuclear transportation for crew safety to get there faster?
I don't think it's necessary, right? That's an important point, which is like, what is necessary and what is like a nice to have. And so what is necessary is we've got to have boil off prevention. You've got to have massive, like, heavy lift capacity into low Earth orbit. You've got to have enough money for it. Obviously, you've got to have the ability to land safely, the ability to fly back, the ability to set up HABs of some kind on the surface and support them and provide power and things like that. And I think, somewhere on that list is like, wouldn't it be nice if we could get there a bit faster? But actually, if you have the ability to lift 1 million tons of cargo into low Earth orbit per year, you can actually like go quite a bit faster just to chemical propulsion, right? Like there's no rule saying that like your trans-Mars injection burn has to be 4.2 kilometers a second. You can burn at 5.5 kilometers a second and get there a month faster if you really want to. It just takes a bit more fuel. And so if you're designing your program around like a SLS type rocket where like the fuel you've got in low Earth orbit is what you've got, then you're kind of stuck. But if you're designing a system where your Starship is launching stuff to orbit every day and 90% of it is fuel anyway, it's relatively easier to say, well, for the cargo, we'll take the 8-month trajectory, but for the humans, we'll take the 6 or the 5-month trajectory, and it's a little bit faster, improves our margins on life support, a bit more comfortable for the crew. But yeah, I don't know, like something 60 or 70 of my ancestors went out to Australia, most of them voluntarily, and on ships that took between 4 and 11
Most
months
of
to get
them.
there. All but 2, yeah, as far as I know. Some of them even did it more than once. Some of them went back and then came back again. Like imagine they didn't live that long in those days, and they spent probably 3 or 4 years of their lives on ships. Yeah, I think life support is a nice problem to have, right? Imagine if you're like, oh, well, the Starship works flawlessly and it can land on Mars and it costs like $10 million a shot and it can fly back from Mars and we've got the fuel plant set up, but the life support system to get to Mars is like a bit iffy. Like that's a very nice problem to have because that's so much easier to solve.
Do you think there's a market that would sustain a private company's plans to go to Mars? I'm assuming this is not going to be government project. This is going to be SpaceX's project, or maybe I don't know, Dell Web will want to develop a development on Mars, so it'll be a Dell Web development. Do you think there's going to be a market for humans getting to Mars?
Yeah, I mean, I think that individuals will be able to pay money to go there. In terms of like the key stakeholder, I'm pretty dubious about the idea that you can actually make enough money with space resources to pay for the whole operation. I think like individual parts of it could be self-sustaining, right? So like the crew transportation part you could pay for example, depending on how wealthy the people who are going are. I think the more meaningful question you say is, well, let's say that Starlink is profitable enough that Elon is able to spend $5 billion a year on this program, right? Which is a lot of money, right? How much bang for your buck can you get for $5 billion a year? Like how much cargo can you get to Mars for that price? How many people can you support on Mars for that price? And then you can still run, even though it's technically running at a loss, you can still use the engine of capitalism to kind of help adjudicate market and like resource allocation problems and achieve steadily greater productivity over time. But yeah, it seems to me to be a pretty tough problem at least until the base is able to be economically self-sustaining. But like, I think either way, you still have to somewhat philanthropically drop 1 million tons of cargo there one way or another. So that's going to be not cheap.
Is advanced propulsion going to materialize with something exotic and make our life easier? Antimatter, wormholes, any of the things you hear talked about by all sorts of people. Movies are made about them. What's
Yeah.
your guess? You're a theoretical physicist. What's your guess if you go real theoretical? What's plausible in
Yeah.
in
They're very helpful in movies, right? To help the plot. And I went to Caltech in part to study warp drive. Like I wanted to understand how that would work. But I wrote a blog post a couple of days ago actually on antimatter propulsion, and there's kind of this is idea doing the rounds right now that if you take away SLS and Orion from the NASA centers, they should get something to do, right? You don't want to fire everyone there necessarily. So like what would they do? And you say, well, some people have floated the idea of doing nuclear electric propulsion, right? You say, well, your program now is to develop, a $10 billion nuclear electric thruster to help us get to Mars faster or something. And I looked at the math and it doesn't make a whole lot of sense to me. Like it seems to me that a nuclear electric thruster is slower than a solar electric one. Like for the same amount of money, for the same amount of mass, you can use a giant solar panel and get better performance, or even a solar sail in some cases. Unless you're like out beyond Saturn or something, right? If you're that far from the sun, then it's maybe different rules apply. But also Elon has said, and I agree that like if you have people going to and from Mars, then suddenly you'll have like a really strong existential forcing function for better transportation technology, and then like it'll be relatively trivial to like go and raise the money to improve rocket engine technology. But I actually think like if you had to think like what will take us beyond chemical propulsion plus 1 million tons to orbit a year, it would have to be antimatter, something like antimatter, because you still have the engines still have to be light, right? You still have to have a high thrust system. You don't really want to have a giant particle accelerator in your rocket, so you need some way of storing liquid anti-hydrogen in like electrostatic trap, and then like using it to heat like steam exhaust to 20 to 40,000 seconds or something like that. So you get like the really high mass flow rate and also the really high exhaust velocity, but without using any really exotic materials. Like room temperature superconductors and stuff is a bit exotic for my tastes. So yeah, if I was in charge, if I was Vinny Bush, I'd say let's go and spend $10 billion on antimatter propulsion and make that work. And the really nice thing about it is once you solve those puzzles, antimatter production on Earth, antimatter storage, and antimatter use, it's not just about going to Mars, right? You could plausibly fly a human exploration mission to Pluto and back, because you could have 100 kilometers of delta V in the tank, which is a lot. Whereas current rockets won't really get to more than 6 or 7.
Interesting, but they're not about to cancel all their work on SLS and all that and turn them loose on antimatter or something like that, are they?
I very much doubt it. But actually, it's an interesting point, which is we're kind of reaching this era of like post scarcity with respect to electricity, at least from solar. And so 10 years ago, you could say, well, antimatter propulsion is a nice idea, but where are you going to find your like 500 terawatt power plant to power it? Right. And this is a problem that Leslie Groves faced in the Manhattan Project, which is in order to do uranium enrichment, they needed enormous quantities of electricity, which is one of the reasons why they cited Oak Ridge in the Tennessee Valley, so they could get access to enormous quantities of power. And so we'll have this situation where China, who's installing more solar in months than the United States has ever installed will have this enormous energy supply. And they'll say, well, you know what, maybe it's worthwhile taking a crack at like antimatter mass production. And it has uses other than propulsion to Pluto. It could be, I don't think it's necessarily more practical as a weapon. But, in the context of like extremely high performance, long loiter time, high altitude drones or something like that, I think it could be quite transformational. And also sort of the thing you wouldn't necessarily want to shoot down if it's over your population. So it's certainly the sort of thing where like if you're a DARPA or something like that, you should be looking into it, because the last thing we want to do is find ourselves on the receiving end of like we did in World War II of better technology, at least initially.
Another topic that keeps coming up on space show programs, and there's a lot of disagreement on this too, so everybody may go ballistic and bring it up. It's AI data centers in LEO. Your thoughts on that? So if I can summarize, the thinking is not as convenient as having them on Earth, not a real market for them. They'll need to get rid of heat, and even though they can probably get rid of heat in space, it comes with a cost. And others, especially from the AI industry, think it's the only way they can get sufficient energy for their data centers because they'll get it from the sun. Have you thought about AI data centers in LEO, and what do you think about that idea? Would you thumbs up it or thumbs down it?
Yeah, the idea has been doing the rounds quite a bit recently. I'm kind of skeptical. I think in order to make the idea work, you have to first run some comps, and the first comp should be, what if you take a Starlink version 3 satellite and you throw some GPUs on there? I don't know, 5 or 10 H100, something like that. Is that a net value generator, right? Is it worth the effort to do that? And then the second comp you run is you say, well, what if I took those 10 GPUs and instead of putting them on the Starlink satellite, I put them in the gateway, right? In the SpaceX has a couple hundred ground stations, so you put them instead on those ground stations, right? And then your users, people who are buying inference on the Earth, they're not moving with orbital speed. They probably want their cluster to be local, so they have less latency, right? So then when you're querying, instead of sending a message up and then it kind of bounces around the Starlink constellation for a while until it finds some GPU and then does the calculation and then comes back down, and then now your context has evaporated because it went over the horizon. Instead, it just goes up and back down to your nearest gateway and does a calculation there. And with current technology and even SpaceX's launch costs, even Starlink version 3 and Starship launch costs, it seems to me that you're better off racking your GPUs on the ground, arbitrarily close to gateways, and then sending the inference up and then back down again. But yeah, it's not. I'd say never say never. There's certainly a world where the possibility to develop more power infrastructure on the Earth is so constrained that you have to do it in space. And I mean that's going to be the case ultimately, right? Like we don't like to think about this very much, but in 20 or 30 years at current rates, the AIs will be generating about 1,000 times the GDP per acre of land under solar than we do per acre of land under corn, which means that we're going to get very, very hungry.
Yes.
Since you are a physicist, I'll just say that the energy for data centers on Earth can come from thorium-based molten salt reactor nuclear power plants. That would be much cheaper than, or not just much cheaper, much easier to build and function and maintain than any of these data centers we are talking about. We can build at least 100 megawatt, 200 megawatt, 300 megawatt SMRs using this SMR technologies. MSR technology, TMSR technology. What do you think of that?
As far as I know, no thorium molten salt reactor has ever been commercially successful thus far.
Except in China recently,
They did one recently. Good for them. The other major problem is we need like terawatts of power, right? So like we're manufacturing something like 1.3 terawatts of solar panels globally right now, and it's increasing by about 20% per year. So like over the next 10 years, you could kind of imagine that like we could get a terawatt of solar on the ground. In fact, we will. We put like 690 gigawatts on the ground this year. You could easily get a terawatt on the ground in the next 10 years, right? Now, in order to get something like a terawatt of SMRs on the ground, a 100 megawatt SMR, you need 10,000 of them. Okay, so like, do you really think that China, South Korea, UAE, United States, everyone else combined is going to build and commission 10,000 new reactors in the next 10 years? I don't think that's going to happen. And even if it did, it wouldn't be cheap enough. Now, the only reason you would say, well, let's put the data centers in space is, let's say you have like a near monopoly on launch and a near monopoly on really talented engineers who can build satellites for $100,000 that your competitors spend $100 million on. Then it starts to look like maybe this is a good idea.
United States needs 600 gigawatt of power. So that's 601 gigawatt reactors. That is absolutely doable.
Mm-hmm.
How many nuclear reactors has the United States built in terms of power thus far?
I'm sorry, say
Since
again.
1955. How many nuclear reactors? Like how many gigawatts of nuclear has the United States built since 1955?
No. That's that it has not, but I'm saying that it can, and it should.
I mean, it could, and it's physically possible in the sense that it's physically possible for us to go and build a human outpost on Titan or something. But I just don't think it's necessarily a very good idea.
It's not the right comparison.
I think it's very good. I mean, there was actually, I think it was Nixon. I think Mark Andreessen talks about like Nixon or someone had this like grand bargain idea that like they would that you would say, let's go and build 1,000 1 gigawatt power plants in the United States, and yeah, like plenty of congressional pork gets handed out, and everyone gets to build giant power plants, and the greenies, the coastal granola chomping liberal elite have to eat it because it's nuclear is clean, and the red states have to eat it because it's cheap energy, and the traditional contractors like it because they get a huge handout to go and build all these reactors, and so everyone gets a good piece of the pie, and that's basically what France did.
Molten salt reactors do not require water for cooling.
Water is abundant. It's not a problem.
No, I mean you don't have to be near the water or near the ocean shorelines to be able to have that. You can have them in the desert even.
That's fine. I didn't bring that up. You can put them wherever you want for all I care.
And I'm talking more about small modular reactors, not big 1 gigawatt reactors. Start with small modular reactors for data centers. We were talking about data centers, so I'm just mentioning this. We start with SMRs.
We're in a situation right now where you can put like a 10 gigawatt data center in 18 months, and there's just no way in hell you can power it with. You can't build a nuclear reactor in 18 months. No one's ever done it. Literally, it's never happened. Not even in the like good old days. No one's ever built one in 18 months. So
you can't do that from data center in space either. But you're going to start somewhere. You start somewhere, see if it works, and then
I think that's strictly true. The Starlink satellites spend about 6 hours on the line. So like from components in the loading dock to fully assembled and stacked, ready to go to the Cape at 6 hours. So you could imagine a situation where you're able to, like, ideally in a production situation, the rate limiting step should be the special source, right? It should be the thing that's hard to get, the thing that's hard to make. And so in principle, you can imagine a situation where SpaceX has a factory that's producing Starlink version 3 satellites that are being produced at the rate that's necessary to eat all the GPUs that Jensen can ship from TSMC, right? Like as many GPUs as NVIDIA can provide, they can fly or install or whatever. And that's kind of the situation you see right now with the data centers, right? Like there's no like giant data centers floating around in Virginia waiting for the GPUs to arrive.
May I bring up a point of the version 3 Starlinks basically unfolds a panel in just one direction. And if you joint them and stack them up, they could put them out in 4 directions and probably have enough to run several thousand um, no, several thousand AU chips on the backside, and I don't think there would be hardly any problem in doing that. And once Starship starts delivering them in 50 to 100 per launch, 50 launches a year, there's a huge amount of computing power there. So that is a solution. Turning around and putting it on the ground, yeah, you can take a small nuclear reactor, slap it on, set the data center on it, and you can put them anywhere. You can put them on a mountain. You can put them in Death Valley. It won't matter too much. But the real problem is the communications. And I think Starlink is the communications to connect everything together and communicate it from the ground, from the user to the computers and then back. What's the problem with that idea?
Well, the communication already exists for data centers. All the data centers that exist today.
With coaxial cables, you'll overload the cables.
Yeah, some
I think they're
cable,
fiber
whatever it
optic
is.
cables.
Just fiber.
I was going through Virginia, which has the largest number of just 2 days ago, the largest number of data centers in the country, and huge buildings, lots of data centers.
Yeah,
with
and the electricity in the local area is going up 15% for everybody because they're sucking up so much electricity. Big problem.
Yeah.
Okay,
I'd
so
like
what's
to,
your thoughts? Oh, who's Bill?
Phil, I was just going to say, I'd like to move things back into the space realm again.
Yeah.
And I'd be curious, Casey, to hear your thoughts about Starliner. I read recently that NASA and Boeing were talking about having the next Starliner mission be a cargo only. What do you see as the future for Starliner after that next mission?
Just let it die, man. Like Boeing wants to get out. I'm pretty sure Boeing wants to get out of that whole contract.
Probably.
They're hemorrhaging money. They're hemorrhaging hundreds of millions of dollars a quarter on it. Yeah, just let it die. It was done badly. Put it in a museum of like bad space hardware. You could give it to Johnson
It's hard to
Space
see
Center.
what the business case for it is going forward, given the short
It's already lost more
lifetime for
money
the
than
ISS.
To be fair, Boeing kind of specializes in that, didn't they? I guess Airbus did the same thing, but like Boeing lost so much money on 787 development, they had to sell 1,000 airframes before they'll start to make money, something like that. Bad news, but actually Airbus lost money on A380. I think they made about 250 of them. Kind of mind-boggling, but yeah, I mean I wrote a blog post about Starliner at one point as well. The fundamental problem, I mean, it's got all kinds of problems, but like the fundamental problem is its propulsion system was spec'd wrongly, like 10 years ago, by people who are no longer involved in the project, and the propulsion system is built under contract by Aerojet, and Aerojet doesn't do anything for free, and so your only option to make it work properly is to redesign it from scratch, and you may as well do it in-house at this point, but like it makes almost no difference. It's not going to be cheap. It's not going to be quick. And you say, well, okay, let's say if hypothetically 2 years ago, when like it had become pretty obvious that this is what had to happen, they'd started right now. They'd started right then it's possible by now that they'd be ready to like launch another test flight with the improved, upgraded, correctly built propulsion system for Starliner.
You talking about the maneuvering system or the propulsion system? The maneuvering system?
Whichever, the one that keeps like overheating and breaking down and faulting out is.
Okay. Yeah.
Yeah. There might be more than one. They're in 4 packs, like 4 dog houses around the outside. They messed up their thermals. They messed up their thermals. And then you say, oh, great. Well, we built this capsule that's like always going to play second fiddle to Dragon, right? And for structural reasons, operating costs are always going to be higher. And how long do you think the ISS is going to keep flying for? Like, it's underreported, but it could actually
30 is the max, right?
It could catastrophically fail at any moment, right? There are cracks there are cracks in one of the Russian nodes that are so big, like they tried to patch them, it's hopeless. They're like a meter long, and then when the spacecraft talks, the cracks open up and they lose cubic meters of air at a time. It just goes out. Like if that thing lets go, they'll have like 90 seconds and everyone will suffocate. They'll have 90 seconds to get to one of their escape modules and close the hatch. It's very scary.
As I recall, the engines for SLS, they only made so many space shuttle engines, and there's what, 10, 15 spares or something like that. So if they go beyond Artemis 4 or 5, they have to reopen the engine manufacturing process.
Yep. Same with the OMS engines as well, the AJ10s on the Orion service module.
So
are you done?
so that would cost like $1 billion to reopen the engine factory.
Well, I think you and I both understand that if NASA's problem or NASA's mission was to make some RS-25s again, please, and you're spending your own money, so do it carefully, that it wouldn't cost anything like $1 billion, right? It doesn't cost $1 billion to build an entire car factory, right? Like Tesla's able to stand up an entire new line for the Tesla Model Y for like $100 million. Right? So there's no way in hell that an existing factory with existing tooling should cost $1 billion with a B to like hire a few techs, follow the old textbooks and work orders and so on, and build it again, right? We all know what this is. It's a massive handout to Aerojet Rocketdyne, okay? But that's that way because they want it that way, right? It was done deliberately just to make sure that there was this massive poison pill everyone would have to swallow, and their buddies would get their payday sooner or later. Like it's just rotten, right? There's no reason to do it, right? Even if SLS was a good rocket, even if the solid rockets weren't like death traps in disguise, even if SLS's mass and performance were like reasonable and defensible, even if the core production rate was sensible, right? There's no way in hell you'd put an RS-25 on it. Put a BE-3 on it and call it good. But
Okay.
no one's interested. Yeah, the SSME itself is like, it's very old technology. It's like 50-something years old, and it was badly designed in the first place.
Hey, so you used to work at JPL, right?
Yes, I was never fired.
So my question was, JPL, I think they're pretty good engineers, and yet the cost of Mars sample return is like 8 to 11 billion, according to the last I heard. Why do you think it is that it's so expensive to go out to Mars, get some dirt, and bring it back? Like, what's the fundamental reason?
Well, I mean, it's non-trivial to do that, and it is certainly true that JPL is able to build things cheaply when they want to. So the Mars helicopter, for example, I think cost like $20 million or something, the whole thing. Right? Why? Because it was their own money. Right? But if it's a directed mission, and with Mars sample return, everyone was getting a piece of the pie. In fact, the only part that JPL had was the sample handling, like the part that attaches to the satellite that like grabs the capsule. Maybe a couple of little pieces here and there. But like Lockheed got a piece, the Europeans got a piece, Johnson Space Center got a piece, HQ got a piece, Goddard got a piece, everyone got a piece. They probably spent more money on just like meetings coordinating between people to make sure they could all understand what they were doing than like Rocket Lab would spend on the entire project, given the chance. It was just not I mean, I'm not making this up. There was an OIG report, like a independent inspector general report, I think that like went through this with a fine-tooth comb, wrote a 60-page report that no one ever reads except I read it, gave me nightmares, explaining like what the hell's going on. And it's just like, this is a project where success was not mandatory, right? Just spending money was mandatory, and they got what they wanted. And then halfway through, they're like, oh no, this is much too expensive. What are we going to do about it?
There's no like engineering reason why then. You're saying it's just purely bureaucracy is the problem.
I mean, JPL's engineers, like anywhere else, have limitations, right? But if you said, well, like limit of physics, like what is the absolute cheapest and fastest this mission could be done with humans technology right now? Like $2 billion probably in 6 years, not $11 billion in 12 years. That's assuming correct execution and no major problems and mistakes. But if you look at the architecture they came up with for the Mars sample return landing, it was just like 80% of it would not pass the Elon algorithm of like question requirements and delete unnecessary components, simplify. There's a bunch of stuff there you don't even need.
Yeah.
Like
Did they ever report on?
Sorry, go on.
I was going to say, did they ever report on when they opened it up to commercial providers to provide the bid on the contract? Did they ever talk about what they learned and whether anybody had a better idea than JPL? Like
Well, I
simplification.
mean, Rocket Lab was not
Brilliant.
exactly secretive about their proposal.
Yeah, they didn't get accepted.
And Peter Baker's still trying to sell it, but
Yeah.
but there are obviously parochial interests in place here that are like, well, if it's not our way, no one gets it, you know. And until they can be placated or moved aside, it's not going to happen. Which means, you know, I mean, this was kind of understood that this would happen a long time ago, right? So when the second Mars rover Perseverance, the second nuclear-powered Mars rover Perseverance was being spec'd out, they had a call for like proposals to put instruments on it, and in the end, they didn't put that many instruments on it because they took the major instrument bays inside, about 250 kilograms of capacity for various instruments, and they allocated to a sample handling system on the basis of the fact that they'd go out and drill some rocks and cache them and save them for future reference, right? And yeah, and so that now we've got this rover trundling around on Mars, looking at all kinds of interesting stuff, procuring samples that the people involved knew would probably never get collected, right? Or if they do, they'll get collected by Chinese astronauts or something in the future. Yeah, which is pretty dismal. You might have thought you should think that one through first. Yeah, it's a bit depressing, but you know, JPL's I don't want to put the boot in too much. JPL's really suffered badly over the last couple of years.
Yeah.
Partly as a result of losing this business, but like when I was at JPL, they were absolutely humming, like stuffed to the gills. They had 4 major projects going on at the same time, and Europa Clipper, Psyche, Perseverance, and I can't remember the other one, NISAR maybe, and they're pretty much all launched now. And so like it's a real bust cycle there. I think they've laid off 1,500 people, many of whom lost houses in the fires earlier this year. It's really tragic. And again, it's just like the writing was on the wall. I wrote an internal policy paper in 2019, which I subsequently published most of. I put it through the release process there and then published it on my blog, basically saying like, regardless of how you feel about Starship, Falcon is here. Falcon landed in 2015. We're post-scarcity with respect to launch. We're now in a position where we should be setting ourselves up to launch an orbiter and a lander to every planet in every launch window, which is roughly once a year. And there's no reason why we shouldn't do it. We could do it for $1 billion. It's well within JPL's current existing budget. If we did it, we'd have job security forever, right? We'd set up a production line and we'd be making, you know, a new rover every 2 years, making a new orbiter every year, making all these different things, rovers and landers and helicopters and things. At the same time, build some spacecraft that'll sit out near JDOST and wait for the next extrasolar comet to come through and then blast off and go and intercept it. You know, you have to have something in orbit already to go and chase it. It would be super cool, and it wouldn't be all that expensive. You know, each of these missions could be at, you know, even for JPL money, like maybe $100 million. If someone else is doing it, maybe more like $20 million. And instead, the people involved, unfortunately, you know, a little bit like the kind of macro problem we see with like the NASA administrators thinking it's not their job to tell Congress what's possible and what's not possible. They're kind of like, well, we just kind of sit around waiting for Congress or NASA to say, please do this for us. I'm like, yeah, but like, look down the pike. Like, there's not much business on its way in. A lot of what JPL has traditionally been really good at has been subsumed by the commercial sector. Like JPL used to be absolutely heroically good at making custom silicon and custom software to run these, you know, robotic spacecraft in deep space. But the Mars helicopter ran on a Snapdragon processor, right, running Linux. So you don't need any of that anymore. There's no competitive advantage of having that anymore. No one's going to fork out $1 billion to get that special piece of the pie anymore. You can just buy some hardware off the shelf for a couple $100. It'll do the job just as well.
Yeah.
It's very sad. So, you know, the problem remains, which is like, you know, all the NASA centers, about 15 NASA centers were kind of stood up over the last 70 years to do very particular missions. And a lot of those missions have kind of gone by the wayside. And so either these centers need to get reorganized or get a new mission or a new area of excellence to push towards, or they should be sold off. Because you can't have people sitting there on payroll consuming tax dollars not doing anything. It needs to be a place that's embodying precedence and superlatives. So it's a place that ambitious people want to go and work, to be like at the cutting edge of some particular technology, not to be like, oh, I'm going to go and do some custom silicon on a project that got overtaken by the private sector 25 years ago.
Yeah, we were discussing like last week that we said that one of the problems I think happens is that we have this idea in our heads, like the public has an idea in their heads that these missions aren't expensive, that if the commercial sector took over, they'd be way cheaper, and that therefore we're wasting our money on NASA and JPL. And I think that's a false sort of basis for making those judgments. I think these missions are expensive and they are hard to do. And people, if it wasn't this like we're getting ripped off feeling out there, I think JPL would probably still be in existence today.
Well, JPL is still very much in existence.
I mean,
but
yeah, you're right. Sorry.
It's lost about a quarter of its stuff, I'd say, maybe a fifth, something like that. JPL is still very much in existence. No, I think there is a perception by the public, and I think it's not entirely without merit that that NASA and JPL and many other government agencies are not run with anything like the same level of fiscal discipline as a private industry, as a private entrepreneur, right? Everyone has an uncle who like runs a restaurant or something like that, knows what it feels like when you can't make payroll, and yet at NASA, the reward for like delivering SLS, 12 years late and $50 billion over budget is congratulations, here, have some more money. It's bullshit. It's not how a real organization can and should be run. And I saw this firsthand when I was at JPL. I've spoken about this in other podcasts. It's not a secret anymore. I worked there for just under 4 years, and I was formally reprimanded 5 times. 5 times. What for? What did I do? Steal some stationery? No. I made the cardinal error of writing down, committing to writing ways that I'd found of saving significant amounts of time and money on the schedule. Right? Not interested. There's no incentive whatsoever. There's zero incentive. There is negative incentive to save time and money. And so you can't really turn around and act surprised that the Mars rover cost $2.4 billion to build something that's about as complicated as a Ferrari. And Ferrari, who certainly like puts love and care into their products, can't seem to figure out how to put more than $10 or $20 million worth of labor into one car. And somehow JPL is like 100x over that. It's absolutely mind-boggling. There's zero incentive to move quickly or save money.
Is the same thing going on at APL, or do they run differently than JPL?
I don't know of a single agency, and there's hundreds of them, 400 and something agencies that actually has the incentives aligned towards incentivizing internal employees to save time and money. Which is part of the reason that Doge like went in and did stuff, whatever you may say about it. But like, there's part of the reason that Trump was reelected is that like there's a definite perception that the federal government does not spend your money as carefully as you do. And it's from my first-hand experience at NASA, I can say it's absolutely 100% correct. Sure, you have to get like 3 layers of approvals to like upgrade a keyboard for your computer or something like that, or like get a whiteboard. But when it comes to like, by the way, guys, like this technology came along 5 years ago, and it can allow us to build this $5 million 5-year instrument in an afternoon. Are you interested? No, we're not interested. Why not? Well, we need to spend $5 million to keep everyone employed.
If you don't spend it, you'll lose it. That's their attitude.
Well, I mean, that's part of it, but also if we're not like, if that $5 million is paying for the salaries of like 20 like engineers to build it a certain way, what are they going to do? It's not like these engineers can magically learn how to do it a different way,
or magically get another job.
Well, you're not even firing them. At JPL, you wouldn't necessarily get fired, but you'd have to find work at some other team or on some other project. And some people are really versatile. They're comfortable and natural, like moving between different projects and different schemes. But some people get very set in their ways, and it's very hard to like take someone who's quite productive, writing custom firmware for custom silicon on some spacecraft and say, okay, great, now I need you to set up your IDE so you can program the Xilinx dev board to do the same project in like half an hour. Of course, it's 2025 now. We have AIs that can do this pretty well for us. But in 2020 or 2021, it was, it's a real concern. Like their major problem is feeding the machine. It's finding work for everyone who works there doing what they already do. It's when I'm feeling spicy, I say it has shadows of the Politburo and their price fixing apparatus, because it's completely insulated from market forces.
Totally change directions because we don't have much time left for the program. Your number one topic for space, what do you want to focus most of your energy on, or complain about, or support? What, good or bad, what has risen to number one for you regarding space?
Well, I think in the United States, at least, we should definitely orient around asking ourselves the question and then answering the question of like, what does it take to get NASA to the level of operational capacity where we don't lie in bed awake at night wondering if we're going to lose them into China, right? Where it's like, yeah, of course, it'll be fine. Don't worry about it. Yeah, like when we think, so when the B2s and the F-35s flew across Iran and did Midnight Hammer, right, and took out Natan's facility, right? as soon as you heard that happened, did you really wonder like, oh, I wonder if like the Iranian SAMs managed to shoot one down? No, it's like, yeah, they'll be fine. Don't worry about it. Yeah, and that's not the situation we have with NASA right now. Right now, we're like, yeah, I really hope that like the NASA hardware doesn't like just explode on the launch pad, which is like, yeah, not how we should be feeling about it. And unfortunately, like it's like I don't want to gild the lily here. It's a really bad situation, right? Like NASA's operational capacity right now is at an all-time low. It is far, far below what it should be or what it needs to be to uphold US strategic interests, right? And it's only got that way through decades of neglect. Okay. And if you think that this can be turned around quickly or easily or cheaply or unpainfully, you're crazy. Absolutely crazy. Like what took decades to mess up, you think it's going to take, we don't have decades to fix it. It's a really dire problem. But I believe that a NASA that's succeeding with maybe a few hurt feelings along the way is more important than a NASA that's not succeeding, but everyone gets a trophy.
Agree with that.
Before we close out, you have a company that you created
Yeah.
to create a unique approach to space solar power. Do I have that right? Sort of right.
Not exactly. Actually, speaking of Thunderfoot, I'm sure he would absolutely love what I'm doing here. And if he gets into this interview, I'm sure he'll write me a love letter about it. We're doing synthetic fuel. So it's kind of inspired in a sense by the like building up a primary material supply chain on Mars. But it turns out on Earth, you also need a primary material supply chain. So we're talking oil and gas. Now, oil and gas we get from underground as the remains of ancient creatures and plants. It's kind of geologically processed over hundreds of millions of years.
Right.
But ultimately, that carbon, that hydrocarbon, it came like the plant lived in the ground and it absorbed oxygen and CO2 from the air, and it absorbed water out of the ground normally, and formed a woody body, or like a plant-like body that was then smashed and turned into coal, oil, or gas. And yeah, it turns out like some very, very clever French and German synthetic chemists between about 1895 and 1925 figured out how to do this with air. And they initially focused on ammonia production for making artificial fertilizer. But the process is pretty similar for making oil and gas. And so that's what we're doing here. And actually, like the Nazi war machine largely ran on this technology. Like the Nazi war machine depended on synthetic gasoline produced using this process with coal as its precursor. But we're looking to a future where we don't depend on coal, where instead we rely on solar power. So our machine is a system. We're based here in Los Angeles and Burbank, California. And actually just across the road was where Skunkworks used to be. We take air and water and copious quantities of electricity and perform a series of chemical processes on it to produce natural gas. Pretty soon we'll be producing a methanol, which is a good precursor for liquid hydrocarbons as well, which is be very exciting. So yeah, it's super cool. It's yeah, California is the place to be. Imagine some schmuck like me gets a chance to work on something like this. Absolute dream. An incredible team, and what an opportunity. Like this, a startup, small chance of success. But in that case, we will unlock energy abundance for all of humanity forever. In 1,000 years' time, in 10,000 years' time, our children's children will be flying supersonically around the world to visit their friends using synthetic fuel, because we sure as hell won't have any naturally occurring fossil oil by that point. So yeah, that's what we're working on.
And California's okay with your working with fossil fuels and doing this?
Yeah. I mean, permitting, like land permitting in California is quite painful compared to say Texas. But California is the place to be because it's at least for me, it's been a culture that's been very nurturing in terms of entrepreneurship, and there's a lot of entrepreneurial wealth that's generated here, which in turn supports our work. So can't complain. It's I have some friends working on similar technology in Europe, and it's absolutely pulling teeth for them to kind of get social permission to try and do something this weird.
Anybody in the group have a final?
Is there anyone I have not yet offended?
Ryan, do you
Yeah.
want to say something?
Yeah. Just focusing on the Terraform Industries. And so from the website, in addition to the hydrocarbons, you're also looking at iron, titanium, cement, coke. Yeah. Like so an entire primary material like food chain, if you will, right?
Yeah, we are hiring. So I'm actually looking to hire people to come and work on this project full time. Right now, they're site kind of nights and weekends projects for us. Um, but no, if you're like, well, we take solar power and raw materials and turn it into useful things, mostly by ripping oxygen off it, um, then basalt is high on my list of things that I would like to refine. Because basalt's about 15 or 20 bucks a ton, and the net present value of the metals in basalt's about $1,300 per ton. So it's almost a 100x increase in value if you can obtain sufficient quantities of cheap energy and then separate the various elements in a sufficiently clever way. It's a good challenge, and it's also a technology we'll need on Mars, where you can imagine a landing site that has the appropriate characteristics for landing large quantities of cargo, so it's not too high, and enough solar power, so it's not too close to the poles, and enough water, so it's not too far from the poles, and also like maybe one mineral, if you're lucky, one particular mineral, so maybe like a bunch of iron. But if you want anything else, you probably either have to like drive a very, very long way to find some mine somewhere else, or take advantage of basalts, like basically melange mix of like random minerals that come out of volcanoes, and of which there's plenty on Mars, and then separate into its constituent elements.
So then, I guess for the metals production, then are you looking at a process that's similar to like the molten regolith process, or I mean, can you say what processes you are looking at there?
Oh, I'm looking at a bunch of different ideas.
Okay.
Yeah. So it's actually kind of fun. So you're like, well, if I had infinite free energy, how would I do it? Right. So like, I'm not talking 1,000 thorium molten salt reactors. I'm talking like 1 billion thorium molten salt reactors. And it turns out that you could do something like uranium enrichment, where you just turn everything to plasma, and then shoot it down a mass spectrometer, and then separate it up by atomic mass. That's probably a bit profligate even for me. On the other end of the spectrum, you say, well, you can do chemical separation, so you can dissolve it all in like some powerful acid, and then selectively precipitate each of the ions you want as you go along, which I think is I don't kind of There's a time and a place for doing kind of pH-based separation, and then in the in-betweens you're basically dissolving rocks in some molten salt or cryolite or something like that, and electrolyzing, or selectively reducing one way or another. And so I'd say it's probably somewhere in between. The key thing though is, if you're using cheap solar power, you need to find a process that's got very low capex per kilowatt. So conventional refineries and metal processing plants and stuff would be like on the order of $2,000 to $5,000-6,000 per kilowatt, and in order to use cheap solar, you need to be more like $200 per kilowatt. So generally, what that means is you need a process that's very energetic but also very quick. So like your traditional blast furnace might take 6 hours to process, and that's much too slow. Like you if you're doing iron reduction, you probably want to do it in like 3 seconds, in order to be able to get high enough throughput through a small enough device that you can actually afford to pay for it. But other than that, it's a mystery. And if you want to work on it, then send your resume this way, or alternatively raise your own money and start your own company. Many varieties of pain and suffering on offer.
Anyone else have a comment or question for Casey?
Well, you did say that you'd talked to Elon Musk at one point. Can you give us a backstory on that?
Yeah. So I guess 2011, he offered a SpaceX tour to a bunch of Caltech grad students, and via one of the professors there. So we went along, and he came in and did Q&A for a couple of minutes, and I asked him about that dragon thing. But actually, I just put in the chat, like if you Google,
I saw that.
Was dragon designed for that? Then you find it there. So I wasted a question. To be fair, I don't think that was in public record at that point. But if you ever do interview Elon, don't ask a question that anyone else has ever asked. What a waste of time.
He used to come on the show a couple of times in his early days, but I've not been in touch with him for a long, long time. I'd like to talk to him again, but we'll see.
He's pretty busy.
Yeah,
you should come back.
To save
you should come back, and you should get Phil Mason. You should get Thunderfoot and Elon on at the same time. And
that'd be awesome. Well, that would put you to the top of the ratings pretty quick.
Who can make that happen?
Elon.
Casey, want to thank you very much for coming back on, and I hope some people listen to you and we make it to the moon.
Yeah, absolutely. I mean, I'm not that religious about how we do it. I just want it to happen one way or another. And I think that we do have a kind of playbook for for solving difficult technical problems with high technical integrity. And actually, I think Jared's the man to do it. He's what a mensch. He's a super nice guy, and yeah, really good track record. So let's all cross our fingers for him tomorrow.
Okay, we will be in touch soon, and thank you again for being with us and for everyone also joining in and participating. Back again Friday morning with our English science author. Have a good night, and once again, Casey, thank you for returning to the space show. Hope to talk to you soon.
My pleasure.
Bye-bye.
Thank you.
Thank you. Yeah, it's a great
Bye.
show.